Good day, this is Sheena Mia Pagaduan from BSED Math 2A, and for today's video, we'll discuss the topic about the mean, variance, standard deviation, and expectation for probability distribution. The mean, variance, and standard deviation for probability distribution are computed differently from mean, variance, and standard deviation from samples and populations. In Chapter 3, the mean for a sample or population was computed by adding the values and dividing the total number of values as shown in this formula. But how would you compute the mean of the number of spots when a die is rolled? You could try rolling the die, say 10 times, recording the number of spots and finding the mean. However, this answer would only approximate the true mean. What about 50 rolls or 100 rolls? Actually, the more times the die is rolled, the better approximation. How many times must the die be rolled to get the exact answer? It must be rolled an infinite number of times. Since the time is impossible, the previous formula cannot be used because the denominator would be infinity. Hence, a new method of computing the mean is necessary. This method gives the exact theoretical value of the mean as if it were possible to roll the die an infinite number of times. Before the formula is stated, let's have an example to explain the concept. Suppose two coins are tossed repeatedly and the number of heads that occur is recorded. What will be the mean of the number of heads? The sample space in the example is head head, head tail, tail head, and tail tail. And each outcome has a probability of 1/4. In a long run, you would expect two heads to occur approximately of the time 1/4, one head to occur approximately of the time 1/2, and no heads to occur approximately of the time 1/4. Hence, on average, you would expect the number of heads to be 1/4 multiplied by 2 plus 1/2 multiplied by 1 plus 1/4 multiplied by 0 is equal to 1. If it were possible to toss the coins many times or an infinite number of times, the average of the number of heads would be 1. Therefore, to find the mean for a probability distribution, you must multiply each possible outcome by its corresponding probability and find the sum of the products. Then, the formula for the mean for probability distribution is mean is equal to x sub 1 multiplied by p of x sub 1 plus x sub 2 multiplied by p of x sub 2 plus x sub 3 multiplied by p of x sub 3 plus x sub n multiplied by p of x sub n. Or simply, mean is equal to summation of x multiplied by p of x, where x sub 1, x sub 2, x sub 3 to x sub n are the outcomes, and p of x sub 1, p of x sub 2, and p of x sub 3 and p of x sub n are the corresponding probability. Note, summation of x multiplied by probability of x means to sum the product. Let's have another example. Rolling a die. Find the mean of the number of spots that appear when a die is tossed. When the die is rolled, the outcome is 1, 2, 3, 4, 5, and 6. And each of the outcome has a probability of 1/6. Then, to solve the mean, we use the formula mean is equal to summation of x multiplied by probability of x is equal to 1 multiplied by 1/6 plus 2 multiplied by 1/6 plus 3 multiplied by 1/6 and 4 multiplied by 1/6 and 5 multiplied by 1/6 plus 6 multiplied by 1/6 is equal to 21 over 6 or simply 3.5 or 3.5. When a die is tossed many times, the theoretical mean will be 3.5. Note that even though the die cannot show a 3.5, the theoretical average is 3.5. The reason why this formula gives the theoretical mean is that in a long run, each outcome would occur approximately of the time. Hence, multiplying the outcome by its corresponding probability and finding the sum will yield the theoretical mean. In other words, outcome 1 would occur approximately 1 over 6 of the time, outcome 2 would occur approximately 1 over 6 of the time, etc. Example, in a family with 2 children, find the mean of the number of children who will be girls. Solution. The probability of having none girl is 1 over 4. The probability of 1 girl is 1/2, and the probability of 2 girls is 1/4. Then, using the formula, mean is equal to summation of outcome times probability of outcome is equal to 0 times 1/4 plus 1 times 1/2 plus 2 times 1/4 is equal to 1. Therefore, the average of having a girl in the family is 1. How about the variance and standard deviation? In a probability distribution, the mean of the random variable describes the measure of a so-called long run, but it does not tell anything about the spread of the distribution. Recall from the chapter 3 that in order to measure this spread of variability, statisticians use the variance and standard deviation. And this formula was used. Variance is equal to summation of x minus mean square all over n, or standard deviation is equal to square root of summation of x minus mean square all over n. So this formula cannot be used in probability distribution since n is infinite. Then, the variance and standard deviation are computed differently. To find the variance for a random variable or a probability distribution, subtract the theoretical mean of the random variable from each outcome and square the difference. Then multiply each difference by its corresponding probability and add the product. Finding the variance by using this formula is somewhat tedious. So for simplified computation, a shortcut formula can be used. This formula is algebraically equivalent to the longer one, and it's used in the example that follow. Find the variance of a probability distribution by multiplying the square of each outcome by its corresponding probability, summing those products, and subtracting the square of the mean. The formula for the variance of a probability distribution is variance is equal to summation of x squared multiplied by probability of x minus mean square. And the standard deviation of a probability distribution is the square root of variance. Let's have an example. A box contains 5 balls. 2 are number 3, 1 is number 4, and 2 are number 5. The balls are mixed and 1 is selected at random. After a ball is selected, its number is recorded. Then it is replaced. If the experiment is repeated many times, find the variance and standard deviation of the number of the balls. Solution. The outcomes are 3, 4, and 5. The probability of outcome of getting number 3 is 2/5. The probability of getting number 4 is 1/5, and the probability of getting number 5 is 2/5. First, let's solve for the mean. Mean is equal to 3 times 2/5 plus 4 times 1/5 plus 5 times 2/5 is equal to 4. And we can solve for the variance. Variance is equal to summation of x squared times probability of x minus mean square is equal to 3 squared times 2/5 plus 4 square times 1/5 plus 5 square times 2/5 minus 4 square is equal to 16, and 4/5 minus 16 is equal to 4/5. The standard deviation is square root of 4/5 is equal to square root of 0.8 is equal to 0.894. The mean, variance, and standard deviation can also found using vertical column, where x, or the outcome, is 3, 4, and 5, and the probability of outcome is 0.4, 0.2, and 0.4. And in the third column is the outcome multiplied by probability of outcome, where 3 times 0.4 is equal to 1.2, 4 times 0.2 is equal to 0.8, and 5 times 0.4 is equal to 2. And in the fourth column is the outcome square times probability of outcome, where 3 square times 0.4 is equal to 3.6, 4 square times 0.2 is equal to 3.2, and 5 square times 0.4 is equal to 10. In the mean, just add the value in the third column. 1.2 plus 0.8 plus 2 is equal to 4. Then, to solve the variance, just add the value in the fourth column. 3.6 plus 3.2 plus 10 is equal to 16.8. And subtract mean square. Hence, variance is equal to 16.8 minus 16 is equal to 0.8. Then, to solve the standard deviation is equal to square root of variance, or square root of 0.8 is equal to 0.894. Expectation is another concept related to the mean for a probability distribution is that of expected value or expectation. Expected value is used in various types of games of chance, in insurance, and in other areas such as decision theory. The expected value of a discrete random variable of a probability distribution is the theoretical average of the variable. The formula is mean is equal to expected value is equal to summation of x multiplied by probability of x. The symbol e of x is used for the expected value. The formula for the expected value is the same as the formula of mean. The expected value then is the theoretical mean of the probability distribution. That is, expected value is equal to mean. When expected value problem involve money, it is customary to round the answer to the nearest cent. Let's have an example. 1,000 tickets are sold at $1 each for a color television value at $350. What is the expected value of the gain if you purchase one ticket? Solution. The problem can be set up as gain, or the outcome of win, is $349, lose -$1. The probability of win is 1 all over 1,000, and the probability of lose is 999 all over 1,000. Two things should be noted. First, for a win, the net gain $349 since you do not get the cost of the ticket back. Second, for a loss, the gain is represented by a negative number, in this case, -$1. Then, expected value is equal to $349 times 1 all over 1,000 plus -$1 times 999 over 1,000 is equal to -$0.65. Note that the expectation is -$0.65. This does not mean that you lose $0.65, since you can only win a television set value at $350 or lose $1 on the ticket. What this expectation means is that average of the losses is $0.65 for each of the 1,000 tickets holder. Here is another way of looking at this situation. If you purchase one ticket each week over a long time, the average loss would be $0.65 per ticket, since theoretical, on average, you would win the set once for each 1,000 ticket purchase. Another example, 1,000 tickets are sold at $1 each for 4 prices of $100, $50, $25, and $10. After each prize drawing, the winning ticket is then returned to the pool of tickets. What is the expected value if you purchase 2 tickets? Solution. The problem can be set up as gain or the outcome of $98, $48, $23, $8, and negative $2. The probability of getting $98 is 2 all over 1,000. Probability of getting $48 is 2 all over 1,000. Probability of getting $23 is 2 all over 1,000. Probability of getting $8 is 2 all over 1,000, and the probability of getting negative 2 is 998 all over 1,000. Then expected value is equal to $98 times 2 over 1,000 plus $48 times 2 over 1,000 plus $23 times 2 over 1,000 plus $8 times 2 over 1,000 plus negative $2 times 992 over 1,000 is equal to negative 1.63. Therefore, the expected value if you purchase 2 tickets is negative $1.63. And that's all for today. Thank you for listening.